Hey guys, hope you're doing well. What we're going to cover today is we are going to look at erosion. And so our learning target today is I can compare erosion by water, wind, ice, and gravity. And what we're going to see with those four types of erosion, we're going to see how it affects various landforms. So, as I just said, here are the four types of agents for erosion: water, wind, ice, and gravity. And so erosion, by definition, is the process by which the products of weathering are transported. So we've already talked about weathering. Back in our last week, we're still continuing that lab in class with mechanical and chemical weathering, which we still got a lot to do and accomplish with that lab. Since you guys just finished the first part of that lab, which was the mechanical weathering of marble, looking at granite and halite. And so one thing we talk about with weathering is basically the breaking down of rock. And so we looked at mechanical and chemical weathering. But erosion is basically the transportation of that weathered material. How does that stuff move? Okay, when it's eroded, how does it go from point A to point B? And so here are the four most common types of ways that stuff gets moved. Okay, so let's look at the first one, which is erosion via the agent of water. So water is the most efficient and effective agent for erosion. When we look at erosion with the agent of water, it usually occurs in two different settings, one being at coast with the ocean, and then two being with streams and rivers. Those are the two most common areas we see erosion by water take place, which makes sense. At the ocean, you have crashing of waves. At the coastline, which carries the sand and stuff out to sea, or sometimes can bring sand in. It just varies. So that's one agent of erosion. The other type is streams and rivers. Streams and rivers go from higher elevation to lower elevation due to gravity. And so as we're going from higher to lower elevation, depending on the slope that you have, the severity of going from a high location depends on how fast those waters are moving. So if those waters are moving very fast, typically we may see higher amounts of erosion. If those waters are moving slower, typically a little less. Just depends. It also depends on, too, if the rivers or streams are meandering quite a bit or if they're fairly straight. So those things can vary as well. But those are the areas we typically see erosion. So right here is a picture on the left-hand side of somewhere on the coast of some country. I'm not sure which, but you can see over time those homes that live fairly close to those cliffs probably are not going to be there for much longer because the crashing of those waves will cause that soil to erode and move out to sea. There on the right we have looks like a river, and you see on the right hand side it looks like there used to be a road there, but it's starting to experience erosion just due to the water moving. The water's moving, it's going to carry some of that soil, loosen up the soil, and cause it to erode and move out with it. Also, too, with erosion can shape landforms by water. When water's moving over a surface, it can cause that surface to change its shape. So when we look at the left image there, streams or rivers, what they do is over time, it's kind of like water moves like a shovel. As water moves, it's slowly picking up the particles at the bottom. If you look in ecology terms, we call the bottom layer of a river the benthic layer. So we look at the bottom part of the river, and it's basically shoveling out, and as it does that, the river gets deeper and deeper. So if you look at the image on the left, the reason that image looks that way is because over time that creek stream has made that turn into what we call a V-shaped valley, where it's very steep. And at one point, I bet that river was much higher up, but over time it's cut into that slope. Other things as well, if you look at an image on the right, you see that river is fairly flat, but what we believe is over time that river or stream has really actually shaped this area right here. It's kind of made it into its own valley here. We don't believe that valley has been there that whole time. We think this river right here has actually cut into this major valley right here and has made it flat. Not really a V shape, but fairly flat. Another important feature that you guys probably know of is the Grand Canyon. The Grand Canyon has been shaped via water erosion. As you see here, hopefully you know this. This is good geology, and I know sometimes we struggle with geography and stuff, but the river that goes through Grand Canyon is called the Colorado River, and so it comes from Colorado and works its way down out to the coast, more towards the Pacific coast. And so as that Colorado River is moving through the Grand Canyon, it has made the Grand Canyon deeper. As you can see here, this water is moving in some direction, and as it moves through, it basically shovels, it digs into the ground. And so at one point, this Grand Canyon, I bet the river was up here at one point. But as the Colorado River has come through, it's dug and dug and dug and made the shape of the Grand Canyon it is that we see today. So the reason the Grand Canyon is the way it looks is due to the Colorado River moving through it. Now, the next one is erosion by wind. This is typically in drier environments. There's not a lot of vegetation, as you see in these images right here. You don't see much vegetation. When there's not much vegetation, there's not much areas for you to block that wind. Around here, we don't have to worry so much about wind because we have a lot of trees and vegetation that stop a lot of the wind. So we really don't worry too much about wind erosion. But when you go out west, to especially the Midwest, they do have a lot of wind. If you go out to desert areas, there's no vegetation out there. So wind can actually shape the rocks and cause things to move as well. Wind can pick up things and cause them to bang into other things. We call those abrasions, as we see in these rocks here. Wind has probably picked up smaller rocks or sand, fine particles, and has moved them and bombarded these rocks and caused them to look at the way they do. You don't see this in areas around here because we have vegetation. But if you go out Midwest, wind can be a factor in causing things to erode. Just think about if we're going to pull out a history example here, the Dust Bowl. The reason the Dust Bowl occurred was because of humans. What we were doing is we were tilling into the ground, loosening up the soil, and what happened is it's really windy out Midwest because there's hardly any trees out there. It's just plains out there, and so where we were tilling and trying to grow crops, we were loosening up the topsoil about 22, 24 inches into the topsoil. Wind comes through, it picks up that soil, and that's why we have the Dust Bowl. And that's where we had the Great Recession and stuff like that, because we didn't have a lot of food and there weren't a lot of jobs. And that's where we grow a lot of our crops out west. You can see right here another example, wind erosion that occurs. These areas can create sand dunes. If you go out to Oak Island, certain areas on the East Coast, like the Outer Banks, that has these sand dunes. These sand dunes were created via wind erosion. The next one is erosion by ice. So glaciers, when we say ice, we're talking about these massive glaciers. Today on planet Earth, about 10% of Earth is covered with glaciers, ice. That's steadily decreasing, as we know, due to global warming and the increase of the greenhouse effect. But at one point, it was up to 30% the Earth was covered in ice. And at some points, we've had the Ice Age where it was quite a bit. And so when ice covers up Earth, that ice eventually can move, it can slide, and it can melt. And so a lot of the features that we know about on Earth, we can see how ice has moved over these surfaces and carved out these surfaces. So some examples, if we're going to look at in the United States that you may know about, is Yosemite Valley, Glacier National Park, the Grand Tetons. Many things, if we go up to Alaska where there's ice up there, ice has shaped a lot of our environment and has caused some erosion. So you can see in a picture right here, which is spectacular, of how this looks like a river, but this is actually frozen ice. And this frozen ice has eventually carved into this mountainscape and could eventually melt and dry up and give us like a river valley through here. In this particular area. Some indications that we know ice erosion has occurred is due to the striations that exist on certain rock features. So if you look right here, these are abrasions, like I told you guys earlier. Those were wind abrasions. But these right here are abrasions from ice sliding over a hard surface. And so usually when we see that, we see these particular bandings that occur on the rock itself. And so typically when we have ice involved with erosion, typically it's a form of mechanical weathering. Just like we talked about with ice wedging when we looked at the examples of mechanical weathering, if I remember correctly. We looked at unloading, we looked at frost wedging, and the third one's not kind of biological activity are the three ways that we can have mechanical weathering. But ice is an example of that. Right here, these are glaciated valleys. At one point, there were ice filled in these valleys. Ice was covering all the way up to the tops here, but these valleys were created from ice being frozen, basically gnawing down into the earth, causing it to erode and eventually move out towards the sea. The last type of erosion we're going to look at is via gravity. This is probably one, I'd say besides water, the one we're most familiar with. I wouldn't say we're really familiar with glacier erosion and wind around here, but gravity is an example of erosion. Remember, erosion is the product of weathering and where it moves. So erosion is kind of the way you get there. We see right here gravity is occurring. We see any type of loose and impediments, any type of weathered material, gravity exists. And so what happens is the center core of the earth is pulling on those materials. And if they're loosened by any types of weathering, those agents will fall down via gravity. So gravity is basically the catalyst for all of this. So hopefully you guys can compare all the types of erosion and the effects they have on particular land masses. If you guys have any questions, please let me know, and I will hopefully see you guys tomorrow.